Today, I'm going to present a project titled as Waste Collection Management System for Domestic Waste Disposal based on AI. Hi, my name is Jong-Hwa from K1 University of Art and Design. The content has been divided into the 5 sections from introduction, communication status for resource circulation to conclusion. This paper classifies its received data based on the CCTV video data using artificial intelligence to detect household waste and implements a control system that can efficiently turn waste into circulating resources. Jeju Island is limited to a world-class tourist destination or island, and the disposal of household waste has become a very important issue since the implementation of the volume rate garbage disposal system. As of 2018, the resident population of Jeju Island is almost 600,000, and the number of the tourists reaches 40 million, causing serious social problems as the capacity to dispose of the household waste reaches majority in 2020. This study classifies waste types by using the learning effect of the CCTV's waste image data and provide the information to the collection vehicle according to the moment of waste, thereby efficiently tracking the location of the waste disposer in large quantities. Figure 1 shows a shift in the awareness of the waste policies. As an introduction, goal is establishment of the resource circulation society. Polish environment is about raw materials, energy depletion, climate change. Major tasks are circular sources, performance manage, energization, and the treatment of the waste resources, etc. Purchase strategies has been focused on the efficient products, consumer materials recycling, energy recovery, and advancement. In Jeju Island, the average daily amount of the waste of the discharge was 1,300 tons in 2019, and the waste treatment facility reaches saturation, and the daily waste emission per person increased by 23.3% per year to 1.63 kilograms, which is a serious social problem. Figure 1 shows the garbage dumped on the side of the road by tourists. The average amount of the waste generated in the tourism industry for the 3 years from 2019 to 2021 was 67,670 tons. Among them, waste generated by the tourism and the lodging industry was 57,724 tons, accounting for the 85.3% of the total. In the case of the peak tourism season from June to August, despite the same collection cycle as in the off-season, the status of the waste treatment is very serious. Next, for the communication status for the resource circulation. From the 3 p.m. to the 4 a.m. the next day, items designated for each day of the week were to be discarded on the day of the week. Table 2 shows the contents of the household waste discarded by day of the week. As shown in Table 3, you can see the public relations and the poster writing journals, which are waste reduction campaigns. Jeju City provides pre-information services on the separate discharge of the recycled products, such as title, classification, name, days, explanations, method, and precautions related to the pre-information on the separate discharge of the recycled product. Table 4 shows the Jeju City's separate discarded open API guide through the domestic and the foreign tourist information website. The method of the discharging essential item for recycling product is carried and disposed of by the reservation, discharge, visit collection date, and the collection at the recycling center. Through this project, circulating resources system for the household waste based on AI has been managed. For the greenhouse and IoT position, CCTV checks installed in the clean houses and the fines have been put on the tourist company vehicles. It is necessary to describe the shape of the trash and mark it in international terms. Figure 2 shows an efficient management system plan for the waste collection vehicle based on the Internet of Things, IoT, CCTV, and artificial intelligence to be installed for each clean house. As shown in Figure 3, IoT device block diagram. This page is explaining about applicable for the AI algorithm. In Figure 4, the data provided for the deep learning of AI uses predictive modeling and is required to determine whether the waste image is inside or outside the waste container, whether the system is confused or in the specific situation. The upper layer determines whether the waste is inside or outside the dumping container, notifies the moving vehicle and the manager app, and informs the clean house location information. Figure 4 shows a schematic explanation for the learning of image analysis for such as a waste dumping. Figure 5 shows the grid cell algorithm with the error backpropagation multiplier perception method. This page shows the experimental result. The IoT terminal proceeds from the device temperature of minus 30 Celsius degree to the plus 85 Celsius degree, operating the temperature of minus 10 Celsius degree to the plus 65 Celsius degree, and the relative humidity of 0 to 80% in the test chamber based on the electrical test specification. Figure 6 shows a radioactive disturbance has waveform according to the frequency of the environment within following conditions. Figure 7a shows the simulation result of the box and the letter. B, the metal can on the box. C, the glass soju bottle, and etc. In addition, it is possible to distinguish between the shape of the waste and the type of the dumping located inside and outside the waste container by constructing data set through the various tests such as glass bottles, plastic water bottles, and vinyl as a view from above. The final waste information to be classified requires the establishment of the long-term data on the influx of the tourists in the 4 seasons, the amount of the waste in the morning and afternoon, and restaurants and the general residential areas. Figure 8 shows the vehicle's location map. Therefore, with this result, it is possible to use an efficient operation policy by operating the garbage collection vehicle according to the number index assigned to the IoT and predicting the collection cycle and the quantities. In particular, an efficient method may appeal when the policy purpose or the strategy is consistent with the results of the field review, but it cannot be fundamental solution. Figure 9 shows the map information idea for information and location by clean house. According to the result of the image data analysis, the garbage collection vehicle moves to the location where IoT is installed, such as decision making, user knowledge, expression, and the IoT are installed. In conclusion, the world is conducting a lot of research on the problem of household waste treatment. This paper is an example of applying IT technology to collect household waste generated from the Jeju Island, where the area is limited, and use them as circulating sources. Through the operation of the clean house in Jeju, the garbage disposal time is carried out from the 3 p.m. to dawn, and each trash can is classified and treated by the type, and the types of the garbage disposal are different for the days of the week. So it generally has the advantages of establishing quantitative estimation and operation strategies. In particular, the change in the amount of the garbage can be known through the change of the tourists in the fourth season within the 670,000 resident population and 13.4 million, which is a good example of the garbage volume research. On AI and IoT-based household waste monitoring system was implemented, and an efficient waste disposal and management plan was proposed for this. Accordingly, an IoT device that can provide information by linking existing CCTV bits to the clean house site was developed, and an artificial intelligence algorithm was used to analyze the garbage image data set of the installed CCTV cameras. Through this study, Jeju Island's research cases, which are limited to many countries around the world who want to study household waste, will be a good sample. Thank you for watching this presentation.